Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be reviewing the DOFReality H6 motion platform, a true 6DOF motion experience for only $3,800 plus shipping. Time to put it through the SRG's review process and see how they are able to do this. So, let's get to it. I'm going to give you a quick closer look at this motor, and this is actually not the one that we're going to be using on my H6 review. We've got some upgraded motors and different ratios, gear ratios in our gearboxes here. So I'm just showing you this one because it's one of the old ones, and it's just easier to show you because I got the others mounted all together and they're heavy to lift. So anyway, the basic concept is the same here. Nothing's changed as far as that goes. So we have your electric motor. We have it driving in a gearbox here, right? And that gearbox obviously is going to drive our lever. And because this is just a motor, there's no encoder on it, there's no resolver or any of that stuff for communicating back to the controller board. We have a rotary resistor here. This is kind of an industrial unit, and it's coupled to the shaft, the other end of this shaft, so that when this shaft gets turned, then this will report the position back to the controller board, and that's how we control it. Instead of having, again, an encoder or a resolver stacked on the back here like you do on a servo motor setup. Right. So it's pretty simple what we're looking at here. The plugs here, we have a 3-prong here for power. So that's how we're going to control the motor, with the power and based on what we're getting as far as position sensing off this data cable. And that will go into the controller box too. And we'll see that once we get there. So again, there's not a lot I can show you like this with it all together. So what I've decided to do, and I didn't do it when I did the H2 or the H3 review, but I'm going to do it for this one. That is pull this assembly apart and show you, at least as much apart as I need to show you how how this works and how it's put together. So let's take a look inside of this assembly that allows us to create motion for our rig. First off, I'm going to pull the motor off. A heavy little unit here. And remember, this is a 3,000 RPM motor, but the newer motors are 1,500, right? So we have a flange here that has the 4 bolt holes that obviously let us attach it to this adapter. And also you can see that there's the shaft in the middle, and we have a sealed bearing in there. Shielded, actually. That's a shielded bearing, not sealed. Shielded's got the metal part. All right. And you can see on this shaft, we have a key. Go this way, maybe you can see it better. How about against my shirt? There we go. All right, so there's a little groove cut into or machined into this shaft. And then they press this key in there. That's what we call that piece of metal, a key. So that indexes into the hollow part of our shaft in here so that we're able to do some work with this motor. And that is turn the shaft that's in here. See the hollowed out shaft? There's the little slot for the keyway. And it just inserts in there and then turns it. Very simple, right? Typical. You see this a lot with motors, electric motors that do any work in machinery. Now I'm going to go ahead and pull this adapter plate off, and you can see this is actually a nice aluminum bit. You can see how it's been machined out there, little grooves, and cut some weight out of it. And it has obviously 4 holes on the outside and 4 on the inside in a smaller diameter. The 4 holes on the outside, of course, are for the flange on our electric motor again, right? The 4 on the interior diameter are so that they fit our gearbox right there, those 4 there. And you can see the bearings right there. We'll see more of that though, that this is actually supporting our shaft here. All right. Now there is a seal in here, again, because of the transmission fluid that's in this stuff. Yeah, you can see it's wet because of the transmission fluid, and this is what it looks like. It's brown. Kind of a reddish brown. Typically what you'll see in a gearbox. And this is a pretty good seal, actually. I'll give you guys a look at it here on the bright light. You can see it has a little cavity in between the 2 seal lips. I'll go ahead and flip it around that way. You can see the same thing. No spring in here to reinforce it, but yeah, this seal is just like any other seal I see. And I used to build motors and stuff like everybody else, right? And yeah, it's very similar to that stuff. A very good seal. It doesn't leak, so it's got to be good. And we can see there's actually some sealant around this. You can see that white stuff there. See that on the edges there? So yeah, it's got some sealant on it that fits down inside of here when it goes on. Right. Put that over there. And we're making a mess because of the seal is wet. Man, stuff always, you never get all the transmission fluid or oil out of these things, it seems. Okay, so because we don't have encoder resolver, we obviously are going to use this potentiometer here to sense what position this lever is in from where it's been turned, right? So we know how to control, or we let the controller board and the driver control this locator as far as the location of our lever here. Right, so I'm going to pull this off. And these are the 2 bolts that hold it on, just keep it from moving in and out and stabilize it while it's under use. And these are M6 bolts. Go ahead and pull that out. And they are 55 millimeters long, so pretty long. I'm going to put it over here. And let me pull this one out. And then we'll have it loose as far as the potentiometer goes. Not all the way loose because it's attached to this coupler. See how I can actually turn this coupler and it doesn't move. The potentiometer doesn't. All right, so because the potentiometer obviously has its own shaft in there that's moving. So I'm going to pull this out of the coupler. There we go. Set this back down and show you. It's typical of any potentiometer, or most of them anyway. It has that flat spot on it. See the little flat spot there, so that we can tighten one of these bolts down on it and hold it so it doesn't move. It is very easy to move, by the way. Yeah, pretty easy. But not a lot of slop in it as far as in and out. There's a little bit of lash, but there has to be some, obviously, or it won't turn. So yeah, seems like a pretty good one. Let's go ahead and take a look at the model number if you guys are interested in that kind of thing. There it is. Made in Mexico. All right. So we know what that does and how it's coupled. Let's look at the coupler itself. See if I can get this off. Loosen this screw here. There we go. All right. And of course, this is the other side of the shaft that goes all the way through this gearbox and turns the lever. All right, this is a cool coupler. It's aluminum. We have a larger hole on one side than the other. And of course, that's because we have a smaller piece here that's coming out the other side of the shaft, right? Then, of course, the shaft that's in the potentiometer. Right, all custom stuff. And you can see there's some grooves cut in the middle of this, right? See those grooves? And you can actually take this and squish it. See how they open up? Or they close down, depending on which way you're looking at it. So that's kind of a dampening deal, all right? So it's not a stiff connection between the shaft and the potentiometer shaft, because that might cause vibrations and throw some readings off. So yeah, this is pretty cool the way they do this. Again, it's all aluminum, and they take it, let's see if I can find it. There it is. See how the first line starts on the top, and then you can see all the way at the bottom, it ends. So that's how they do this, to keep this as one piece, but still give it that springy capacity, all right? Make it go up and down. And of course, a little bit this way, you can turn it, rotation this way, in a torsional type of rotation. So very cool little unit here. Again, all this is pretty nice looking kit. No junky stuff here, really. Everything's just doing its job. Now, what are we going to look at next? Okay, so the shaft just comes out. Let me show you that real quick, I guess. All right, and it has its own keyways and keys in it. You see two of the main ones here. And we also have a key on here that is pressed. This lever here is pressed onto the shaft with that key. So everything turns something. And I was going to pull this off, but it was pretty stiff, and I didn't feel like, pressing it off. You guys get the idea, right? All right, I'm going to put that back in. Because, before I do that, let me just show you how that shaft is. It's hollowed out shaft. The key goes all the way through this. So, let's see, you guys can see it. There it is. There's the other end of it. Let me put it against my white shirt, maybe. Anyway. So, pretty simple. It's just a shaft. And this shaft either has a gear bolted to it, or it might be a one-piece machine, but there's a gear going around this that engages the gear that's on this shaft. I'm going to put this back in and show you what I mean by that. Now, this is a 50-to-1 gear ratio on here. Does that sound I took it out of? Sometimes you got to put it back in the same way it came out. I think I took it out of this side. Or it just doesn't want to go back in. Yeah, there you go. All right, and I just know that because I've worked on a lot of stuff. All right, so let's take a look at this worm gear. First, if we turn this, one thing you want to know, that the gear ratio 1 to 50, which means that's about straight up right there, and I'm looking where the keyway is, its location. And 1 to 50 means if I turn this 50 times, completely around 50 times, this should move all the way around one rotation. So as an experiment, I'm going to rotate it 10 times and see how far it goes. 3, 4, 5, 6, 7, 8, 9, and there's 10. Right about there. All right, so you can see it didn't go a full quarter turn. So I would say that's about a fifth. Okay, so yeah, this is definitely a 1 to 50 ratio on this. So that's how that works. If I turn another 40 times, it'll go all the way around. But we're not going to do that because we just want to get the idea here. Now I'm going to take this drain plug off. And that's what this little plug here is, or fill plug or whatever. And we're going to be able to see, without me having to press all these bearings out and everything, how this really works. All right, if you look down in there, you can see some grooves. And that's, of course, on this shaft as it goes down. And this, we call this a worm gear, all right, because it kind of moves up and down as you turn it. I'm going to turn this, and you can see the gears moving. See how it goes either up, and right now it's going down because of the rotation I'm putting on it. But if I turn it the other way, they go up. And of course, you can see my levers turning based on what I'm doing here. All right, pretty cool, huh? So that's how it works. Pretty simple stuff. So yeah, now that I know how all this works and goes together, I have a better idea what's going on with the mechanics of my motion, and that helps me maybe understand some other things that I may not once I get to actually using this system. So yep, there we have it. Get this transmission fluid off of me, and yeah, there it is. Look inside. Now that we've taken a closer look and a look inside on this motor gearbox assembly, on how each one of these is assembled and how it works, now we can mount them to our bars here that are going to interface with our Hexagon frame that's going to position everything where it needs to be and sits on the floor. And we'll look at that in just a minute. These bars are kind of a rectangular shape, as you can see. All right. We've got 2 holes in them. Let's get my cable out of the way here. We got a hole here, and we have a hole here. Now we also have holes on the bottom of these. I'm going to very carefully turn this up over here and over here. And that's for these feet. So you get 6 of these feet. They're going to screw right into those holes. These are M10 threaded feet, and they're adjustable. They have this nut on them. And of course, once we screw it in, I usually use the nut, leave the nut rather all the way down. And then once I screw it into where I need it to be level, then I'll screw the nut up, and that will lock it. So it'll be nice and level on my floor. And we also have I'm not sure the size of this. It looks like to be about a 20, maybe 22 millimeter hex on this. So we can actually turn this with a wrench if we got to do some fine tuning adjustment, and we can't do it with our fingers. So we get 6 of these, and we'll be putting them on the bottom as you saw there. Now these 2 holes here are going to interface with the, like I said before, the Hexagon frame. And I'm going to show you a quick shot of it here. And yeah, pretty simple stuff. What we're going to be using is these 75 millimeter M8 bolts. And you can see they have the long solid shank and then threads at the end. Of course, the solid shank part is what's going to be inside of here. So yeah, it won't be resting or sitting on the threads. It'll be sitting on the shank part. Very cool. I like the way when they do bolts this way. This is an M6 metric on the top. Simple enough. And again, we have 1 washer and 1 nylock nut. And you can see it's got that blue stuff in there, blue plastic that will, or this might even be black. Anyway, so that locks onto the threads and keeps the nut from backing off due to vibrations. And we're just going to be, let me flip this back up, pushing this through just like that. And it will interface with our Hexagon frame. And I'm going to show you that right now. And you'll get a better look at it once I'm on the floor putting this together. Cord out of the way. And this is what it looks like. A hexagon, right? So, yeah. And this is all obviously already welded together as far as the frame goes. I think I can set it right like this. Yeah, there we go. All right. And you can see we have an L here, little flange. So what's going to happen is this bar here is going to sit along this little channel here. All right. And there's our holes for mounting it. So it'll be sitting, this assembly here, the motor assembly is going to be sitting on the outside and on top of this lip. And then we'll put our bolts in again, like I did before, through the bottom. Oops, it's already there. And then it'll come out this side here. Or actually, it'll come out the other side over here on the inside. So then we'll put our nut on, right? Pretty simple stuff, and you'll see it better once I get it over there on the floor. But I just wanted to show you, this is a nice steel frame here. It's got good welds in it. Actually, they finished the welds pretty well. They ground them down, like you can see here. They ground them down quite well there before they did the finish on them, so it looks very neat. So they did a good job with this. And this is 3mm thick as far as the steel. So it should give us a good platform. I think the biggest thing of this is just to put these in the right position as far as the motors to make sure that the motion works like it's supposed to. And of course, also support the stresses that are going to be transferred from this bar through the whole frame. So this whole frame here will take care of that. Right. Anything else we want to talk about here? This is very simple stuff here. Again, I had to put my motors on these bars. Remember, I had an H2 review and an H3 review, and I had 3 motors for the H3. So I took those motors off the H3 chassis and I put them on a spare bar that they sent me, and 2 spare bars actually. And they sent me some extra motors, so I had to mount all this on here. It's not hard to do if you are going to convert it, and I'm just mentioning this because you may be converting from an H3 or an H2. It's pretty simple the way this goes on. You can see we have these 4 bolts on the bottom here, right? And in the motor, as you saw before, when you did the closer look, you can see how that's attached. It goes all the way through. It's an M6 bolt, and we have an M10 nut down there and a washer. And that's also a nylock nut. And that's how it goes on. It's very simple. Now, I did discover an easier way to do it than just try to get all 4 bolts in there and then doing the nuts. You could do it that way, just kind of set it on top and mess with it that way. Or you can just put 2 of these bolts in and kind of pre-stage it by putting your 10mm bolt on, or rather nut on the bolt, but make it loose, leave it loose. Then you can take the whole motor or the gearbox and slide it into those, right? And then once you've done that, you can just kind of secure it, snug it up a bit, and then you won't have it flopping around while you're over here working on these 2, right? That's just the way I did it. Once I took a look at it and figured out, well, you really don't have to take these, completely off when I was doing the motor swap. So again, if you're upgrading, that's what you'll have to do. Not a big deal. Didn't take much time, but yeah, just something to be aware of. And this is heavy stuff, so be aware of that. When you've got 2 of these motors on one of these bars, it's not light at all. All right, so now that we've talked about what we're going to do, and yeah, we'll just go ahead, get it on the floor, and start doing some video on putting it together. Now, before we go over and mount this assembly to our Hexagon frame, there's one thing I did want to show you guys in case you have an older version like I do. DOFReality has added a new gas damper. All right, so this is a high pressure gassed strut, if you will. That's what we call them anyway, over here in North America. And these are used, typically we'll find these in lifting your bonnets or hoods or the rear hatch on a car or an SUV. These are just in the lift assist role. But these particular ones are in high pressure, under high pressure, and it says do not open under high pressure. So yeah, you don't want to pop one of these open. All right, so you can see it even has a 518 on it. It does work. I've tested each one of these already. I put them in a vise and compressed them to make sure that they work. And these are very, very hard to press in, and we'll talk more about that as the build progresses. But anyway, the newer stuff that you get for an H6 is going to have a hole drilled in this tube right here, going all the way through. And that's so we can attach the bottom part to here, and then we attach the top part to our chassis, the moving chassis, via this adapter bracket. All right, so you can see this is where we would attach the top part. And this is where we're going to attach our 2 arms. DOFReality calls these arms. So we have one that's going to be going down like this, all right, crossing towards that way. Then we have another one that's going to be going this way. And they will be attaching to these 2 pieces here. But our shock is going to be attaching up here, right? But we'll get to that as the build progresses. Now, the problem is I don't have a hole here, right? And my Hexagon, if you saw that over there, and we'll see it again once we get there, there's no hole for it, a bolt either there. So they come up with this adapter, this little bracket here, all right? And this is actually a 4 mil thick piece of steel, all right? And it has a beveled or counterbore piece right here, so we can put a flathead screw in there. See, it's a Phillips flathead screw. And on the other side, that screw goes all the way down. This is an M6 screw, by the way. It goes all the way through this standoff, all right, or a connector. You can use it as a connector or a standoff. And then we have a nylock nut on the bottom there. But we'll talk more about this once we actually start installing our gas shocks. All right, but this thing, our adapter, will fit just like that. So when we're actually bolting this to the Hexagon frame, we're going to be running bolts through this too, and here. And that gives us, obviously, a place to mount our high pressure gas shock for dampening purposes. So I just want to show you guys that so when we get over there, you can see what I'm doing. All right. So now let's take everything over there and get this stuff mounted. All right. So I'm going to give you guys a close-up shot while I'm doing the assembly here of one of these, what I'm calling pods, motor pods. And of course, we have our 2 bolt holes here. We also have 2 in the back on our frame here, our Hexagon frame. And we're going to be using these 75 millimeter M8 hex bolts. There's a 6 millimeter on the top here as far as the driver you need for it. And of course, it's that shank bolt we talked about before. And of course, my adapter here for the gas strut. So I'm going to go ahead and feed one of these in, and I'll get the other one started and just kind of let them hang there. And until I can get to the look around the back, and I'll get the bolt kind of started through the hole a little bit here. Do the same thing to this one. And then I'm going to kind of get my hand underneath this frame. Get my fingers under it. And I'll look down and see it, make sure my holes are aligned. Now I do have to tilt this back a little bit to get this to go in like I want it to. Like that. And we'll get the other one in over here. That's good. And then it's just a matter of putting our washer on and our M8 nylock nut, which is also, by the way, a 13 mil wrench size. Okay, let's get this one over here on. And then I'm going to tighten these down. I have a regular ratchet, manual ratchet back here with a 13 mil socket on it. And in the front here, I'll be using my Milwaukee electric ratchet that has a 6 mil bit on it. And it should be pretty simple to get this done. Like that. All right. So there we have it. Everything's nice and sturdy now. And I'm going to work my way around the Hexagon, of course, and put the other motor pods on. And when we come back, I'll have all that done and we'll take a look at it. So now we have all of the, what I'm calling motor pods mounted now. And yeah, it's all looking good. I'll be putting the controller boxes in the middle of this Hexagon frame. They'll kind of be sitting in there. I think that's the best way to do it. And even in the instructions, I think the PDF instructions, I think they actually say that. But yeah, one thing you want to be mindful of here, you want to make sure that you get these bolts very, very tight. All right, so crank down on them because this is taking a lot of stress and a lot of force and torque. So you want to come back and make sure you got the nuts and the bolts very tight and there's no issues with that. Also, you want to level this thing out. See my feet under here? I've got everything leveled out on the position that's at on my concrete floor right now. So you want to make sure that it's nice and level. You don't want it moving around. All right, so everything looks good at this stage. And yeah, so we'll just get on to the next segment. Now for a closer look at the DOFReality controller box. And we'll have 2 of these with the H6 or a P6 kit because one box controls 3 motors, and obviously we have 6 to control. They're both identical, and we'll talk a little bit about software setup once we get there. And pretty simple stuff here. You can see we have 3 plugs that look very much like the plugs in a computer or something like that. And these are actually power outs, though. You don't plug these into an outlet. This provides the power, which controls the motors, which in turn turn the gearbox, which in turn moves the lever. So these small ones down here are the data plugs. Okay, that's the small round plugs that the motors have on them. And that's coming off of the potentiometer, right? The rotary potentiometer for position sensing purposes. We have a main switch here, and we have a USB type B plug here. Now on the top we have a couple of fans, that's for cooling, and we'll take a better look at that once we get to the look inside segment. On the bottom we have a bunch of ventilation. You can see all the holes there for the ventilation, and no other ventilation holes anywhere else. You can see on the sides, it's all one piece. So they're going for directional airflow, no doubt. And we'll take a look on the back real quick. And here we see a mains plug, just kind of like what we see on the front, but these are actually the male ones, right? So we're going to put a female plug on this and the males on the front. And that keeps you from messing it up, I suppose. So over here we have a 5.5 millimeter DC plug, and that's for our emergency stop button. If you get one with your kit, it's an option. So you can plug it in there and then hit it, and it turns everything off. All right, so not much else to see here. The finish is pretty good on these. Looks like some kind of a powder coat. Yeah, it's either powder coat or, yeah, some kind of a paint, I guess. But it's pretty good finish on it. It's got fingerprints all over it because I've been working with these for a while now. So yeah, no doubt you'll see that. But other than that, it's a very tidy looking box. And yeah, we'll just go ahead and get to the look inside segment next. Now let's take a look inside of the controller box itself. First off, I pulled the cover off, and you can see we have two fans up here. These are 75 millimeter fans, and you can see the labels are pointing inside the case. And typically of a DC fan, the label indicates the direction of the airflow, so airflow is being pushed into the case, in this case. All right. I like the neat, tidy job they do here. Little touches like the twisted up wire here, so it doesn't kind of hang everywhere. So it's pushing air down in the case, and the reason it's doing that is these guys up here, which are our driver boards, right? So these actually control the motors based on what we get from our Arduino over here and its daughter board sitting on top. And you can see it has these huge aluminum heat sinks on each one of these boards across the power transistors. And I got a board here to show you what I'm talking about. And this is a very common board. It's called a Cradle, and it's an MD13S. You guys can get a look at it there in a bright light. And these are the transistors I'm talking about. We have 4 of them here. All right. So the heat sinks are attached to those transistors to suck the heat away from them and make this board have a nice long life. So that's why those heat sinks are there. So the fans, when they're sitting in this case, and it goes on just like this, right? So you can see where those fans are oriented right up here in this left-hand corner area, if you will. So it's blowing air down across these heat sinks and out the bottom, where the bottom has all these vent holes in it. I'll show you that. You can see all the ventilation holes here. Other than these holes and the fans, there are no other holes in this case. So it's definitely a directed airflow. So it can blow all the heat down and out of the bottom. But only my thought would be that, yeah, maybe it'd be better to have it sucking the air out of the top because all the heat rises instead of blowing down on them. But that's just the way this one's set up. But yeah, I'm sure it gets the job done, especially with these huge heat sinks sitting on top of these transistors on the driver boards. We have 3 Meanwell power supplies. These are LRS 350-24s, so they're 24 volt, 350 watt each. And yeah, so we have 3, of course, driving each one of our motors. And we also have in the back here our mains input. We also have a 5.5 DC type of plug here, and that is for our emergency stop, if you have one. And the emergency stop circuitry, you can see the mains coming in down here, and obviously the wires coming off of our DC plug, and they all they route down into this relay. All right, so we got a blue relay here, and that relay is wired into, let me see if I can twist this around a little bit so you can actually see this. It's wired into the L block on this Meanwell power supply, which is a signal block. All right, so this will tell the Meanwells to turn on or turn off. And as long as everything is golden and we don't hit the emergency stop and the circuit stays closed, then all the current will flow. And you can also see on this back piece of red wire coming from this relay over here that on that block we have a looping wire here, and we have another daisy chain over here. So they're all 3 connected. So if we hit the E-stop, then it works like it's supposed to. Everything shuts down. Right. What else do we want to see here? This is the controller stack. At least that's what I'm calling it. And it is an Arduino board underneath. I'm not sure which one. I didn't pull these apart to look at it. But we also have a Sensor Shield version 5.0 dollar border on top. All right. And obviously this is what's doing all the controlling. And then we have these drivers controlling the motors themselves based on what's being sent to them from here. As you can see, we have a blue, white, and yellow wire here on these plugs, and they're looping around and coming back down into each one of our driver boards, right? So that's how we're controlling it. And yeah, very tidy job. Everything is very neat in here. And I always look for that when I'm opening something up, a box that someone's built as far as electronics go, just to see how neat it is. And you can see it's very clean in here. So airflow should be very, very good. And we should get good airflow across these heat sinks in here. All right, anything else we want to look at? I think that's it. We can take a look at the front, but we've already seen the front in a closer look when I just showed you the box. Got to be careful with these fans. But again, here we have our power going to the motors. These are our power outs. And then, of course, we have the data in out plugs down there. And, of course, our main switch and our USB connection. All right, so I guess that's about it for a look inside of the controller box, and we'll move on to the next segment. All right, guys, now we're going to be picking up the pace a little bit and start hooking everything up. Now, of course, we have to have a way to connect the power from our motor and connect it to this floating chassis that's going to be our cockpit right here. All right. Now, there is no way to attach it right here. Obviously, these rod ends, and we'll take a close look at this bar. And it's a 15 millimeter by 15 millimeter square steel stock bar. Of course, we have rod ends at each end like that. They feel pretty good. Not what I would call a top shelf rod end, but yeah, I'm sure that they are good enough to get the job done. And when you hold them in your hand, they seem to have a good weight to them or a nice heft to them. So yeah, I'm sure that they're good enough to get the job done. And we have these brackets. I'm going to show you this cockpit bracket first, and that's what it looks like. We have two M10 bolts here. All right. We have 17 millimeter nuts. We have one here, and that's a locking, pincing, kind of a locking nut there, right? And then we're going to use this to, once we put the rod end on. Okay. And this bottom one is for our gas shock. That's going to be the dampener, but we're not going to use this just yet. We're going to build this thing a little bit before these high pressure shocks come into play. Because I want some leverage on this thing. I'm going to have a seat on it first so I can help push it down once it's on there. This is a very hard shock to push down. I weigh 155, and all my weight pressing down on this on the concrete floor trying to compress it, I can't budge it. So it's pretty stiff. Anyway, we're going to be connecting, obviously, the rod ends here, and then we're going to have a way for connecting it down there. Now, this bracket fits up here, but as you can see, we have two holes here. All right, these are M10 holes, and of course, we have two M10 holes in our bracket. And we also have these big socket head cap heads sitting here. And I'm trying to turn this sideways a little bit. It's going to be sitting like this. All right, it's going to be sitting away from the actual bar with these two big socket bolts here. Let me turn it this way. So you guys can get a good look at this. See the space there? So these things are obviously kicking it out. So we're going to need a nut and some spacing in here for the bolt that goes through here, so that we can pull against this and pull everything tight. So everything's pulled up tight against this surface on this bracket, right? Now, they're going to give you these 35 millimeter M10 bolts. All right, we got a washer on one side. And the idea is we're going to run this through here. And this is tight because of the paint or the anodization, not anodization, but whatever they're using here is kind of tight. So you might have to actually thread the bolt through the holes like this. Not a big deal. In fact, that's why I've got this thing. Makes things like this go much faster. Like that. See, it just kind of popped through there. All right. So once that's done, now we're going to have to figure out the spacing here. Now I know that I have an M10 nut that's going to go on here. And that's to squeeze this just like these guys are doing. See one here? You got the socket head cap, and then you got this locking it together on both sides. Right? Same thing's going to happen here. I'm going to put one of these on. Like that. And then I'm going to lock it down. I'll get my ratchet again. And remember, this is an M17 nut here. So I'll go ahead and just, this will stay on. There we go. I'll just use the box end on this. There we go. That's all it takes. Just snug it up good. Now, I'm going to put this on here like this. Well, not like that, Barry. We're going to put it on like this so that my socket head caps, again, are bumping up against there. And I have to I'm looking down here, straight down, seeing that, yeah, if I put a nut on the end of this right now, it'll pinch it so that it's hanging out over here. So I can actually, with this bracket tight up against this nut, holding with my fingers, I can pull it away when I push these socket heads flat up against here. So I need some kind of a spacer here. So I'm going to try, and they give you some washers. I'm going to try one M10 washer and see where I'm at. That almost does it. I'm going to try two, and I think that'll get it. Try one more. And that should do it, I think. Yeah, that's almost just a hair too much. Coarse, right? So, yeah, I want this bracket to be pulling on these socket head caps. But I have other 10 mil washers. These are kind of thick. These are like 2 mil thick. These are kind of thick. So I think I can come up with a 1 mil one. A couple of them I got in my parts bin to make this fit better. Now, I'm going to do the same thing to the other side while we're sitting here doing nothing. And when you get this bolt, it's come pre-assembled, so you'll have all your washers and everything you should need. So I'm going to go ahead and disassemble this one, pull off the M10 nut, pull off one of the washers, because I want to leave one washer on for the back here, just like I did on this one over here, right? So again, I'll just push this one through. Maybe this one will go through easier. Not quite. Almost, though. So we get our wrench out and take care of it. There we go. And that's fast. Then we're going to put our M10 bolt back on, or nut rather, not a bolt. And then we'll go ahead and snug it up with our closed-in wrench and our M10 hex. There we go. And I'm going to try the same thing over here. I'm going to put one washer on and see where my bracket is. Because sometimes, you know, this stuff is not all even. And yeah, it just doesn't... Well, I tell you what. That looks pretty good. Now that I have it, another washer on this side over here, it looks much better. I'm looking straight down on it here. Still just a little bit of wobble there. So I think I'm going to try one more washer over here now that I have everything looking straight. Oh, and by the way, we want this on the bottom, so don't mount it with it on top like I was getting ready to. Let's see what this does. Yeah, that's just a little bit too much. So I'm going to have to source some other washers for this. But you get the idea. Once this is on, like this, and I've got it spaced correctly, so when I tighten these two nuts up on top of this bolt, everything is flat, pulled up against here and tight, so we've got good bracing. So the idea is you don't want this twisting at all, this bracket, when it's getting pushed on. You want it nice and flat up against this metal here, so everything pulls together, if you will, as a group. And yeah, so that's what you're going to have to do for the spacing. All right, let's talk about, simple enough, let's talk about the actual motor lever doing all the work down here. Now you will get another bolt, and this one is, I believe these are the 35s. Actually, I think that was not a 35 I just put in there. Did I tell you guys a 35? I think it's bigger than that. It's longer than that. Let's see what it is. Let's see. That's definitely not bigger than a 30. It looks more like a 50. Let's see what I got here. Oh, okay. That is a, I'm measuring out a 65 mil for these bolts that we just put in up here. So make a note of that. These, I believe, are the 35s. Let's see, your 30. Oh, here we go. That's actually a 40 mil bolt right here. It came out of these socket ends, so I know that's what they're for. All right, same kind of deal here. We're going to put this into our arm, but before I put it in there, I want it to go through the rod end, like this. Okay? Then I'm going to take another regular M10 nut and thread it on there. Let's lay this down so I can get two hands to it, like this. Just run it down. And then I'll just tighten this up a little bit. Don't need to get real crazy with this as far as tightening it down. It just needs to be snug. So I'm just not even going to use the power on my wrench here. I'm just going to use the wrench and turn it. That's good enough. So it won't go anywhere. Right. So now that we've got that done, we can put this through here like this. Wait a minute. Before we do that, though, don't let me forget. We're putting a lock washer on this bolt here. All right. I can get back out. There we go. I almost forgot. There's a lock washer that goes on. So it'll provide pressure against this plate when we tighten it up. All right. From the other side. So now I can put it through. And I'm probably not going to put it all the way through. There is a clearance issue here between the motor case and this lever. So you want to be mindful of that when you bring your nut into it. Remember, we're putting a nylock nut on that side. Got the little blue nylock in there. And again, a 17 mil M10 nut. So let's see if we can get this guy started. There it goes. And there it is. So there you have it. That's how we assemble the bolt for the bottom part. Simple enough. And I am using the hole, the outside hole on this arm, not the inside hole, because that's what it looks like on the instructions to me. And once I cinch this down and tighten everything down, this will be a nice tight connection, but still be free to move and do whatever it wants to. You can see how the rod end can move. Very cool. So easy stuff here, but it is, you know, we're getting a little busier here as far as the construct or the construction of this system. So what I'm going to do now is I'm going to go ahead and figure this out with the washers I need. And then once I have that the way I want it, I'm going to go ahead and put this bracket on here, right? And I'm obviously going to put one over there and one over here. So everybody has a point, obviously, that I can mount stuff to. And once I have this bracket on, again, we're only going to be using these nylock lock nuts that go on here, right? And tighten everything down. Cool. All right, once obviously we have our rod end on here. So what we're going to do is go over now to the floor, and I'm going to get this stuff bolted together, and when we come back, we'll see how it went. This is what it looks like when we have the main cockpit chassis suspended on the push rods, or connecting rods, or whatever you want to call them. And yeah, you can see them did exactly like I showed you up on the bench. We have the nut on the other side of the rod end, and then we have the nylock nut behind that on the levers. And up here, of course, it's the same thing. I don't have these all the way tightened down yet. I just snugged them up a little bit because, again, I'm going to have to take those off to get that gas rod in to connect from there down to here when we're ready to do that. But we'll cross that bridge when we get to it. So this, I ended up with a couple of washers for my spacing. You can see there's a little bit, I don't know if you guys can tell, there's just a little bit of a bend to that plate. But now everything is very secure as far as these cap heads being pushed up against this bar, just like I wanted it to. And on this side, these guys only took one. And maybe a little bit more bend to that one. I'm not really concerned about the bending because everything's, once you cinch all this down tightly, it's not going anywhere. It's not putting too much stress on that metal plate, I don't think. I've been messing with this stuff for a long time, so I'm pretty confident with that. And I'm the one that's got to be on here, so I want to make sure, obviously, I don't get hurt. All right, so we're actually suspended, floating in the air. Very cool. And now what we'll do is probably just get on to the build where I can at least get the seat mounted before I start messing with those gas shocks. Now I have the gas strut attached to the motion system. It's all assembled now, except for putting the cockpit element on top of it. And I'll talk about that in a second. But this is probably one of the hardest parts, or physically difficult parts, to manage here, because these gas struts here are under a lot of pressure. And I'm weigh 155 pounds, around there, 150, 155. So I could barely get this thing to move with all my weight on it, sitting it on the concrete floor here and trying to press it down. So I got a friend of mine come by. He's about 220 pounds. And yeah, he was able to press it down far enough. And of course, they have a video of this on the system on how to do this on the DOFReality YouTube channel. It's a pretty good one. It shows two guys muscling down this gas strut using the top of the seat as leverage to reattach the rod. So the process is basically, it's pretty simple. Obviously, this is not connected yet when we have these two rod ends up here supporting all the way around here, these three attachment points. You have to take these off so that you can raise one piece of this up at a time, and you do them one at a time. So you can raise this up high enough to get the gas shock to connect to it. And then you have to compress that strut or shock, whatever you want to call it, far enough down to reattach our rod ends, obviously. And that's really a simple process. It just takes a lot of effort to get that gas strut down. And yeah, once it's down, it's fine. And once you get these bolted on, you're good to go. So we did all three, of course, and I did actually do a quick test, and it definitely makes a difference on the way this system moves. But we'll see that once we have the cockpit assembled and everything ready to go. Everything's wired up. Of course, I've been testing it, so everything's moving like it's supposed to. And we will do more testing and talk about the Sim Racing Studio software, obviously, when we're testing it out. So yeah, everything's done except for the cockpit build. Now, the cockpit build I'm not going to do on this video because I've already done that on the DOFReality H2 video. And I'm going to put a link of that in the description, all right? So you guys can check that out if you don't know how to build the cockpit part of it. And basically, everything gets attached to this center spline piece, which, of course, is going to get attached to this cradle here, all right? So when I come back, I'm going to have everything built, all right? And then let me just get on with testing stuff. All right, so I've got the final configuration I'll be using for testing when I'm driving this system. I have my Sparco seat mounted. I have a Thrustmaster TSPC and also the companion GT pedals that we'll be using with it. Now, one thing to note here is when I was mounting the seat, and I've forgotten from the H3 review that I did before how I got a seat mounted. Because the centers, you see these two bars that mount to this spline here. This is sitting on top of the main frame that the motion actuators are actually moving. And that spline bar that I discussed before goes all the way out to the front, and then it goes down and gets our pedal tray attached to it down there. Anyway, the centers for these holes where these bars go are not an industry standard drill. They're about 4 millimeters off as far as the centers go of a standard bracket like this one. You see the mounts there, the holes that are drilled. And this is a Sparco. But I have some other ones that are not Sparcos that are industry standard. They match these holes right here perfectly. So that's just something I want to point out to you guys. Again, I had to go back to my H3 review and figure out how I got these things mounted. And I used this NRG bracket, which itself is a little bit off on the holes where it's drilled at as far as industry standard, or what I think is an industry standard for the spacing. So yeah, I was able to, with everything loosely mounted, get some bolts in, as you can see. And of course, I have two on the other side just like this. So yeah, now the seat is mounted and it's very, very tight. So I'm happy with that. I'm just not happy with the holes not quite being where they needed to be I wanted to use my Sparcos. But, you know, we still got the job done. But if somebody who buys something like this and gets it in their house, you need to be aware of that. And yeah, so I don't know if my sample is the reason why the holes are not exactly where they need to be for something like a Sparco bracket, but something to be aware of when you order this. And I'll always like to point these things out if I run into any issues. The wheelbase mount. Now, I did a review on the wheelbase mount for the H3, obviously, and it was flexy. I mean, end of the day, it was just too flexy. I would not want to mount a direct drive wheel to it or base. But here we have a new accessory that doesn't come with the package. I think it's another $50, but it's a bar that attaches down to the center spline in one of the open holes down there, and it goes all the way up. And it has an adjustment to it. As you can see, there's an M8 bolt sticking in there, and the thinner part comes out the top, or you could have it the other way around, depends on what you want to do. And that gets bolted to another flange hanging down off a separate tube. And again, it's the same size tube as these uprights are that mounts underneath. And they give you longer screws for that in the kit. And that mounts to there, and that stabilizes the wheel deck. And I'm going to do a separate segment on the wheel deck flex and give you a comparison of with and without the bar installed, so you guys can make up your own mind. The pedal tray for these Thrustmasters did not have the correct centers holes. I had to drill my own holes. But then again, this is something that I am quite used to when dealing with builds. It's not something that surprised me. All right, so other than that, the wheel deck itself, the plate, it did have the correct holes for my Thrustmaster, so that's a plus. And yeah, so other than that, the build is complete, and this is how it's going to look when I'm actually driving. My controller boxes are nice and tucked away in the bottom down here, so they're out of harm's way when this thing is moving. I think that probably was the best place to put them instead of out here where I'm walking around. And yeah, I think most people will end up putting them there. Right, so now we'll get on to the next segment. So let's talk a little bit about this wheelbase assembly. First off, there is a new support bar available for $50 as an accessory from DOFReality that you can put between the wheelbase bottom and the frame down there. And the wheelbase obviously consists of these 1-inch tubes that have a lot of holes in them that mount down here to these crossing pieces that mount to the main spline there in the center, right? And there is a bolt that goes in here that attaches to another bar that is mounted underneath the spline here, and you can see how we have 2 bolts holding that. And then we have another bolt on the other side for this arm attaching it to this bar, which does make things tighter with less flex, if you will, but it is a little difficult to get this assembly put together. You have to make sure when you're putting this together that everything stays loose. You don't want to tighten anything up until you have these bolts going through this bar here, because they don't line up really well unless you do that. And even then, it's a bit of a struggle to get one side in, but it did go in, and it's very important that you put this M8 bolt into this tube down here, and this tube is mounted underneath the spline because it really helps reinforce the wheelbase mount. Now, you can see this accessory has a flange down here. Okay, it's a separate flange that you put an M8 bolt in that mounts to the spline, and that will capture this tube here, another 1-inch tube. And you can see we have a locking piece here with a welded on nut, and then we have a thinner piece that goes down inside of it, and of course we clamp it with this bolt. And underneath here we have a whole different piece that they provide for the assembly. Here is the 1-inch tube for our wheelbase, and I hope this is bright enough for you guys to see it, and it goes over and attaches normally. But then we have this separate tube, again a 1-inch tube that's hollow, that stacks underneath it, and it has a flange welded to it right here that captures that tube that's going inside, right? All M8 bolts, and except for this is M6 over here, and they do give you in the kit longer bolts to accommodate the extra 1-inch that you're going to need for the spacing down here, right? So this is, again, an accessory. I'm going to show you without the bar. I'll show you some clips that I made here, and yes, it's pretty springy there. It's moving around a lot. And yeah, so I went ahead and then put the bar in, and now we can see that it's not moving as much. Still has some movement, obviously, but yeah, it's not springy anymore. So that's an important thing to have there, I think. So yeah, a $50 accessory. I would recommend that you buy that when you get one of these cockpits, be it this H6 assembly or the H3 assembly. It's the same deal, right? So yeah, after I had everything bolted together, again, this is about as good as it gets as far as flex. And you can see I can still kind of pop it around a little bit, but it's not really springy anymore, okay? It's settled down real quick after you do that. And of course, when I'm driving it, you'll also see it probably moving. So yeah, I just want to show you that and the new accessory to add on, that I would certainly add on to this because it does help brace it a lot. But then again, you know, it is a strut that is now in the middle of your cockpit that you're going to have to step around to get in and out of the cockpit now. You can't just slide in. So yeah, it's kind of an inconvenience, but with this type of wheelbase, the way that DOFReality has designed this and manufactured it, I would call it essential to help stabilize the wheelbase. Now I want to show you guys the wiring and cabling that I did on this. First off, we have 2 controller boxes, as you're probably aware of if you've been watching the video to this point. And it's a real simple matter here. They want you to do a right side and a left side box. And I've actually put some labels on mine just because I had a labeler, and it just keeps things straight for me when I'm trying to just throw things around here at the SRG, and keeps me on track. Now, there is a sequence that you have to have these plugged in, and that is the right side. We've got 1, 2, 3 motors, and of course the same thing over there on the left side. So they're numbered 1, 2, and 3. 1 is the front one, 2 is the middle one, and 3 is the rear. So it's pretty simple here. It's not really rocket science. Hard to get this messed up. And I actually labeled my plugs also. I took the plugs out, and because they're paired together, it's hard to get them mixed up as far as crossing them over. And I'm going to pull one of these out. And you can see I put a label on here. and it's called right 1 or R1. So I know I'm on the right box with R1. That just, again, just keeps me straight. You don't have to do this because most guys, when they have this plugged in, they're going to be done with it. And yeah, no big deal. So I've got the data plug going to the potentiometer back there on number, well, actually this is number 1, so it's up there. So yeah, that's the potentiometer or data plug. And of course, this is the power. Plug it in and you're good to go. And of course, we have 2 over here and 3 over here. Now, if you look at the box itself from the factory, it has numbers on it. See, there's 1, 2, and 3. So again, it keeps you straight on which motor goes where when you're doing your hookups. Couldn't be easier. And of course, I'm going to be putting a USB plug over here and a power plug in the back when it's actually sitting underneath like that. Right. So also, there is an emergency stop. I believe this is an option. And yes, this emergency stop has 2 plugs on it. And these are 3.5 millimeter DC plugs. Everybody's familiar with this kind of interface, I think. So we have 2 of them because we have one for the box here and we have the one for our box over here. And you can see the plug. And if you saw the closer look of the boxes, you already know where that's at. So I have 2 of them with one switch controlling both boxes at once, which is a good idea, obviously. If something happens and I want to stop it, then of course the usual push it down and yeah, it stops. And then all we do is rotate it and release it. So it couldn't be easier as far as the cabling. Just keep your motors right. And it doesn't matter how you mount these motors, as long as you have the first right one going over here to the first plug and the second one to the second plug and third, and you're good to go. So yeah, it's real simple to get these things cabled up. So now we can take a look at Sim Racing Studio. And this is the application that's going to be controlling our motion system. And obviously Sim Racing Studio has other things that it sells that this application will also control. It has the wind piece. We also have a shake, which is a transducer type of function. We have a tack. If you have one of their tacks, it controls that. And they even have a LED system that you can buy for lighting up your rig or your monitors or what have you. And then of course we have what we're interested in, motion. Now right now we're in the tuning screen for motion, which we're not going to be doing any tuning until we get into the car. And yeah, we'll get to that when we get there. But we're going to set it up and do a little testing just to make sure everything's working right. So you notice I click on the setup tab. That takes us to another screen, and the first thing we see is hardware. All right. We also have some setup stuff for games and things like that. The application games is what you're interested in here, and we can see that it's in game detection is in auto, so it should pick up the game that we're going to be using, which is iRacing. I'm going to scroll down there, see if we can see it. There it is, and it says it's ready to play. So that's what we want. Now, I'm going to go back up here to the hardware and scroll down. Here's the wind setup, where you can set up your wind speed depending on what you want as far as how hard it blows on you. And we have the LEDs, the tack, shakers, and what we're really interested in down here is our motion. Now you can see I've already selected H6, and this software will control all of the DOFReality platforms, but we're using the H6 and that's what's selected. Over here in the hardware status, I can see my IntelliBox is up, which is the wind, which I'm not using in this video. And also it says Shakebox, which I don't have. You can see it doesn't see it, but we can see the motion box, which is the 2 controllers that we have up and running right now. So really what we're interested in doing is testing our pitch, roll, yaw, sway, surge, heave, and traction loss. And I'm going to start with the pitch. And when I take the slider and move it to the right, it should go forward. So let's see what happens. It's going forward. And it's not real smooth, but typically in testing functional motion systems, they're not smooth when you're testing them. I'm going to go backwards. You can see it's kind of jerking there, but hopefully that's not what it's going to do when we're actually using it. Go back forward there. Go back. Okay. There we are. So we can use the slider there, and we'll go ahead and test each one of these. So that was pitch. I'm trying to get 0 here. And the keyboard, you can use it in the numbers on the keyboard to make it go to 0, but that's close enough for now. We're going to roll. And we should be rolling right when we slide to the right. So let's see what happens. And I am rolling to the right. And I'll come back, roll to the left. And it's rolling to the left. So we're good there. All right. Again, it's kind of hard to get it back to 0. That's close enough. Yaw. Okay, now we're going to do the yaw. That should be our yawing left and right. So we're yawing right. There we go. And we're going to yaw back this way to the left, and we're yawing left. So everything's good so far. Sway, that means left and right sway, so I should be moving to the right when I sway, and I do. I'm swaying back to the left, swaying back to the right. All right. Surge. So we should be going forwards and backwards. So let's see if we go forwards to the right. Yep, I surge forward. I'm going to surge backwards. And there we go. So that's good. Everything's working in the right direction there. Let's zero it out. Close as I can get it. There we go. Now heave. That's going to be up and down, so I should go up to the right. I'm going up. A little jerky, but like I said in testing, sometimes that happens. And we'll go back to the down. It's smooth going down. We'll go back to the middle. So we're going in the right direction. So we're looking good so far. And that's 6 right there. Now there's another one for traction loss, which is really yaw. So I'm not sure why the extra one is in there, but we'll move it. And there we go. So traction loss might be a separate entity that's based on obviously yaw. So, but yeah, it's working just like the yaw worked. So we're good to go there. All right. So that's it. That's all the testing you need to do. Now we know what we're working, and we know that in my game, iRacing is in here. We can go back over to the tuning menu. And this is where we're going to spend our time tuning. And you can see right here, this is our motion tuning, right? Well, actually, this is up here. So power max angle, I have that at 100. You can lessen that so it doesn't travel as far. We got smoothing, reaction speed if we want to speed things up, and a boost. All right. And that's for boosting little pieces of the telemetry that are coming into us. Then we have the effects. We can actually tune in some effects here, which include pitch, roll, yaw, lateral, G sway, G surge, decel, and acceleration. So that makes it faster and slower for our surge. Again, these are all things that we can just play around with. Minimum traction loss activation is 0 right now. So if you're getting too much traction loss, I'm imagining we could raise the number here based on other systems that I've tested, and we will have not as much movement and traction loss. Enhanced G-forces is off and on. We'll be testing that though. We'll just check all that out once we get into the car and do a quick tuning session, which we will do next. Now we're going to do a little live tuning session just to see the capabilities of the system and what these sliders do. Let's go ahead and roll this back up. This is divided in actually 3 sections from what I can make of it. And what that means is we have the platform here, right? And then we have effects. Now on the platform is where you're probably going to be making your broadest adjustments, all right? So if I make an adjustment here, it's going to be very broad, and it covers all effects. So the effects down here, you can actually tweak them individually. And we do have a few. We've got pitch, roll, yaw, lateral G sway, which is G force. We have longitudinal G source deceleration and longitudinal G source acceleration. And also road heave. And then these are all G forces, right? Or simulated G forces. And we're not going to really get G force out of this motion system, obviously. That's very hard to do with any motion system. And then we have traction loss down here. We also have yaw up here set at 180. Now, we also have this max telemetry over here. Now, this reminds me, how this functions, it reminds me a lot of SimTools. They have a little applet in there called Tuning Center. And what that means is, if I don't get enough adjustment by using this slider up here, let's say on the lateral G sway, okay, on my sway, and it's just not giving me enough change, then I can actually go in here and reduce this number. If I took this number from 8 to say like 6, all right, and then I save it, this would mean that now this slider, when I moved it, it would generate more sway force, all right? It'd be more intense, in other words. And I'm going to put that back on 8 because that's where it was before. And I might mess with that while we're doing our tuning session. But this magnifies what these sliders will do. And if I went the other direction from 8 to like 10, then it would mean that I'm trying to reduce the amount of effect that I'm getting here when I'm using the slider. Because the slider goes up to 20 and obviously it goes down to 0 on the other end. So I might not have what I want within that range, okay? So this means I can actually tweak that. Pretty cool. So we have 3 ways to tweak it. And we also have and advanced down here, and that's the minimum traction loss activation, and that's at 30, so that determines when traction loss is activated. And you really have to play with that. There's not an instruction manual for this. Sim Racing Studio just doesn't have a lot of information on how to use this application, but especially this newest one that I have running here with this pretty nice graphical user interface, though. I really like this. All right, so without further ado, I have this thing set at smoothing at 50. Some people, again, this is all subjective before we even get started here, so I might have settings here that feel terrible to you. You might have some settings that feel terrible to me, so you just have to do what feels best to you. Let's go with the max angle power. I've got that 100, so that would mean that I'm getting the max power out of these motors. At least that's what I should be getting. Smoothing, again, that's something that probably the last thing I would use after I get down here and do reaction speed and boost. Now, boost is more details, but reaction speed's kind of the same thing. I get more details when I use that too. So I'm just going to stay with the boost for now and just try to describe to you what I'm feeling. Now, I have made some changes down here, all right? And I'm just going to drive it and try to describe to you what's happening. Now, you are going to hear some noise with this system running because we have no less than 18 rod end assemblies in this motion system that are attaching different things. And that includes the gas struts. So there's always some lash in a rod end, and you're going to hear that when this system is moving because of the way it moves with these gearboxes and things. So be prepared for that. All right, and I've got the volume way down on the car so you guys can hear me talking. So we'll just, without further ado, we'll just go ahead and get going. You can see as soon as I take off, and if I hit the brakes, you can see it's diving. So it's real sensitive right now. And this is kind of where I have it set. And I'll play with it a little bit to show you guys if you can see any differences. It's better to be in it feeling the differences than actually trying to watch it on video. But I'm trying to convey it the best I can. And you can see the road bumps, the road textures here. I've got a lot going on. And yeah, it's picking it up very well. Actually, I have to say that this software does a great job of giving the details of the telemetry stream to this system. Now, the system itself, obviously, it's not, you know, the best system out there to have for motion because it consists of so many linkages and a gearbox, and so there's other things involved here. So, but you can see when I go off to the side, it bumps very good. And when I transition, my favorite little test here, when I transition to this concrete, watch it. See that's pretty good. That seems to be right on target as far as the speed that I'm rolling over those concrete spots. And that's why I really like this Sebring track so much for testing, because it has those transitions. When you get to the concrete, it's usually a lot bumpier than it is when you go back to asphalt transitions, right? So, and I'm not really watching the RPMs and stuff, not driving for competitive effect here, just to give you guys an idea what the motion is. I'll hit that curb, and we got some motion on that. Now, I'm not getting any rumble strip motion, even though I'm getting a lot of road detail here. If I hit this curb, I felt that. It tilted sideways, that one too. Now I'm going to go over my usual path here where I jump this well. I'm going too fast. We'll get it next time. But if I jump over here, you can see how much movement you get out of that. Now I can feel the rumble strips in my Thrustmaster wheel, so it's doing its job. And yeah, again, it's just going down the straight. This is a relatively smooth straight, but I can feel the undulations in this seat here. And they're pretty minor from a visual, I'm sure, but I can definitely feel that. Now here we go, 17. Yeah, and you can see it's really moving around here because there's a lot of bumps. And the straightaway, look at this. All right, you can see how much action I'm getting out of this straightaway. And when I hit the brakes, it dives and we get a sway. I don't know how well you're going to be able to see that. When I'm hitting the brakes, it pitches forward, which is the dive part, which is a little bit much for, I think, this GT Ferrari that I'm in. I'm in a 488 GT3. But when I hit the brakes, you can see it pitch, and then it kind of, the whole chassis kind of moves forward. Right there. So it pitches and then kind of slides forward. So we're getting surge effect, and we should, because this is a 6 DOF platform. All right. So now what I'm going to do is stop for a second. And let's go back to the main adjustments. Now I'm going to take some of that boost out, all right? I'm going to put that down to, let's go to 20. There we go. Now, if you have a keyboard, you can use the arrow buttons on the keyboard to move this better than I can with my trackball mouse here. So, yeah, it's a little bit smoother if you do that. All right, so now we're going to go and hit some more spots here and see what the reaction is. It should be less according to what they're saying. And yeah, it's already less, I can tell. All right, so I've turned the boost down. Now it's more of a smooth, you don't feel as much of the detail. Yeah, it's a big difference. You notice it right away. And I think you guys, just from the sound, you can tell that, yeah, it's changed a lot as far as how much detail I'm picking up here. Going over the side bumps, it's still there. But yeah, and we'll see what happens on this concrete patch here. Yeah, it's pretty good right there too. So we're actually just kind of reduced some of the noise out of it, the chatter that we had from all the extreme detail that these laser scan tracks can give you. Another reason why I use iRacing for my testing. But yeah, going over the bumps. And you know what? The sway and the yaw works pretty good here. I'm able to catch my slides and stuff pretty well here. Of course, as soon as I say that, I might miss one. Of course, we're in the grass now, so that doesn't count. All right. All right, I just kissed it. I'm still good. All right, so yeah, it's definitely smoother now. And I'm going to see if I can hit my usual mark here. There we go. Yeah, definitely smoother than it was before. Okay, so that works well. All right, but then we have smoothing up here. And I'm just going to pull that down, way down to like 25. And let's see how much smoothing effect we had on that. All right, here we go. Yeah, I can already, you know, oh no, I got a black flag for that cut in the corner there. Jeez, these black flags, man, kill me. All right, so yeah, now I'm not getting the detail just like I did before when I lowered the boost, but I'm thinking that, let's go around, we'll tell for sure once we get around 17 here, as far as the smoothing. Yeah, it's a lot less smoothing. It feels weird. It feels like the car is, I may have damaged the car, I think. So I'll start all over. But yeah, I took the smoothing out and it's a different feel than the boost. I was thinking that it might be the same, but there's definitely a difference there. So let's get a new car here without damage. I guess I kissed that guardrail a little bit harder than I thought I did. All right. So we're still at smoothing 25. And now there's more detail than when I had the boost turned down. But not a whole lot. So that gives us an opportunity, I think, between boost and smoothing to really get this thing set up. Yeah, it feels a little more comfortable now. It's not, as you guys can probably hear, it's not making as much noise as far as the rod ends chattering. So yeah, this is actually pretty good, I think, for what we have here. You know, I mean, with keeping the expectations within their limits, it's doing the motion. I mean, we're definitely getting 6 DOF here. And it seems to be very fast because, again, this is my timing bump here. And I feel that just as the car is going over it. So the timing is good as far as being in sync, and that one does the same thing. But the first one's a little bit more severe and easier to tell. All right, so yeah, we're getting... This is pretty good, actually. Let me see what happens when I slide. There we go. We're sliding around now. Yeah, okay. All right. Don't hit anything, Barry. Good. So I did that so you guys can see it sliding around. See? Okay. We should be getting our yaw. I can't tell because I can't see it, but I can kind of feel it in the seat. But after a while, it gets kind of blurry because we're doing so much stuff here. All right, let me get out of this grass here so we can get back on the road. That is some slick grass. All right. Okay. All right, so yeah. I'm actually kind of liking it there. It's not as busy as it was before I had it. I guess I was kind of pushing it to the extremes before. And yeah, you will definitely hear those rod ends chattering when you're doing that. So let's go through here. Yeah, that's pretty good. You see it hop over that curbing, and it does a pretty good job with that. So it's picking up the large bumps that we're getting from the telemetry. It does a pretty good job of that. All right. Let's go down and start messing with the tuning effects down here. And what I'm going to do is I'm just going to take the pitch, and I'm going to take it all the way down to 0. And I got a feeling it's still going to pitch because remember our surge, and you can see it just pitched there back. Our surge also is involved. Pitch and surge are kind of combined in almost all motion systems. So that when you, because you want that natural pitch in a surge action anyway, you just don't want something that's pushing you straight without any pitch at all. So you can see how it's kind of mixed in there. Even though, and I hit the brakes, even though when I take all the pitch out, I'll go down the straight here and we'll do it again. So we'll watch the pitch now. Yeah, really, it is less pitch, no doubt. We're getting more of a surge in it now. Okay, so that's working well. So it looks like everything is working like it should here. I'm going to go back up on the pitch. What do I have it, like 5 or something? That's close enough. And we'll hit it again. Yeah, now it's back. So we're pitching a lot more now. That's good. So I think I'm finding that this application, the Sim Racing Studio, is a very good application for motion. They've done a really good job on this from the first time that I tried, I think it was a year or so ago, motion with their application. They've really come a long way with it, not only in the visuals, because this is a nice looking GUI they have now, but also in the way it performs. So yeah, hats off to the guys at SRS for a great application for controlling your motion and tuning your motion, because this is really pretty easy to use. And I'm really getting some results here that I'm pleased with. All right. So yeah, that's kind of all I really wanted to do as far as demonstrating what's going on with the motion here. I really want to, I'm going to go ahead and save this. And it'll tell you which you want to save for. Now you see I only have the Ferrari. I want to point this out while I'm here. The Ferrari 488 GT3 is the only one I have, right? And that's the game iRacing. If I get out of this session and I close iRacing and I go back, let's go ahead and get out of this, and I restart iRacing with another car, let's say the Porsche or something, then this will say Porsche. It will have saved my Ferrari 488 GT3, and that would be in the drop down in here. But I would be on the Porsche now, and any changes I made to that car at this track would take effect there. And that's how this stuff works. I don't see a facility for going in and editing a name. It might be in here, but I looked around, I couldn't find it. So, and again, there's not a whole lot of intuitive, or rather, a whole lot of good information on this app yet. I'm sure there will be in the future as it keeps growing. But yeah, I'm pretty happy with what's going on here with the motion. We are certainly getting 6 DOF of motion out of here. The sway you can feel, and that's mixed in with the yaw, and you can obviously feel the pitch and the surge, and of course the usual roll, heave, and yeah, it's really doing what it's supposed to do. Now again, it's not the most sturdy thing to be in. You guys can see that my wheel here is you know, if you watched, it was kind of flexing around a little bit, and you can hear the chatter from the rod ends. But you know, at the price point this thing's coming in at, you know, $3,800 now it is. I have to say it's doing the job. You know, it's doing what it's advertised to do. But yeah, we'll just go ahead and I'm going to get in and do some real driving now. And I'm also going to, of course, take it over to the dirt trucks and do some jumping in the dirt trucks and see how it works out with that. I can't wait to see that with everything turned up. And see if I can rattle this thing apart or break something. Hopefully, obviously, I won't break anything, but we'll see. So yeah, what we'll do next is just get into the driving session and start having some fun here. So here we are once again in iRacing at Sebring in the Ferrari 488 GT3. And while you're driving with this system, it does an overall good job. It gives you cues that you can feel on what the car is doing. When it slides, when you go over the road bumps. And now some bumps not as much as others, but I think that has to do with iRacing and the laser scan tracks. Some of these curbings hit you harder than others do, and I guess that's just the way the telemetry feed is. So it's not just with this system. But it is a good ride, but it's kind of, I guess I'm trying to get the best word for it without being too derogatory. It's kind of loose and a little bit of slop in everything, all right? And if you turn the effects up real high, which you can do with this system, it's capable of really giving you a jolt. It's still, the sloppiness is still there, it's just that now you're getting sharper jolts when you get hit. And I liked it better with it turned down and without, the roll textures. turned up so much that I could feel every little crack, which this thing actually is capable of doing. Which, you know, being a 6DOF system, you are getting all degrees of freedom in the motion here, which is a big plus over some other systems that I've been on. And yeah, it's just you know, it feels good enough, especially when we think about the price point here, $3,800 for a 6DOF motion system. But of course, at that price point, compromises have to be made for anyone to be able to build and sell something like this and still make enough profit to pay the bills. And yeah, that's what you have to look at this. You have to, you know, keep your expectations in the proper level here for a system like this. It's a little rattly, and that's because obviously we have all these rod ends connecting everything. 18, and that's a lot of rod ends. And every rod end has a little bit of lash in it. And you know, these aren't the industry top spec rod ends either. So again, they're just, you know, they are what they are. And it all goes back to the price point. The system in general is, if you want a 6DOF system and you just want to have something to play with and have a, you know, just have fun with, then this is a good system for that. But don't expect, you know, a rock solid precision feel as far as the motion goes. It is flexy, and it's kind of, you know, just feels a little drifty sometimes. And I actually found it hard to control the car sometimes because I just couldn't really get the feel that I felt that I needed for it out of this system. But it definitely delivers on what it says it does. And of course, you know, other things like the wheelbase mount being flexy, you know, that center mount that helps get rid of that flex should be something I think included in the kit, not something that is something that you buy for another $50, you know, at this price point. But you know, that's just the way it is. So of course I had to go over and really put this thing through its paces, and that's with the Lucas Oil dirt truck. This is the 4x4 dirt racing truck. And this is, you know, jumping this thing is really where, you know, you can put a system through its range all the way as far as what it can do. And you can see that this is definitely going through its range here as we're going through the turns and things like that. And this is also a lot of fun, by the way. You know, again, it's rattling, it's making noises, and it's a little bit jerky at the end of the strokes because of the rod ends and things. But I tell you, the gas struts are a great idea here. I'm glad they implemented the gas struts. If you guys don't have them on your system, I highly suggest you get them, because it smooths things out. You know, without the gas struts, you're going to get more jerkiness than you do already. And of course, the gearboxes on these motors have a little lash in them also, and you know, it's just everything compounds on top of everything else. But I will say that the system did perform. I didn't have any problems with anything. I didn't break anything doing these jumps, and you know, I turned it up actually higher than this doing some jumps, but it was making such a rattling noise that I just didn't think it would, you know, nobody's going to be running it like that all the time. So yeah, that's just something that I just thought would be, you know, just not showing what it's really going to be used like. I don't think anyone would actually run it that high. But again, nothing broke, nothing came loose. Everything was, you know, as far as the construct here, you know, even though when I first looked at it myself, I said, you know, I just, you know, had my doubts about those thin rods that connecting the motor levers to the seat moving chassis part. But, you know, it works. I mean, they've done a good job as far as putting something together that you get a true 6DOF system out of. It's such a very, very low price point. But again, you have to manage your expectations here, like I said before. You know, you can't expect some kind of precision movement out of this particular system. But it will get you in, you know, a seat and get your wheel going, and you will have a true 6DOF system if that's what you want. And, you know, like I said, $3,800 plus shipping. You know, I think that DOFReality set out, or rather accomplished, what they set out to do here. Now we're going to do a quiet test. And I'm going to shut up, and you guys can just listen to this for a little bit and see the more noise it's making. Now, this is not turned up all the way as far as the most rugged feeling I can get out of it. I got some, you know, the smoothings on, things like that. So yeah, it's not the most chattery. And when you have it tuned like this, it actually doesn't make that much noise. I mean, you can get it quieted down. So I'm just going to demonstrate that here. Okay, I guess that's enough of the silent treatment. And yeah, it just, again, shows that it does, no, even when I have it smoothed out here when I'm doing the jumps, it is obviously making some noise. So not something you want to be running next to your significant other if they're trying to get some sleep or somebody's trying to study or something. It might irritate them. But, I think mission accomplished here again from DOFReality. Bringing this in at the price point and, the construction, the materials used reflect that price point. But yeah, at the end of the day, hey, it gets the job done. Final thoughts on the H6 60OF motion system from DOFReality. When you first see the price that DOFReality is charging for a 60OF motion platform, you wonder how they can sell at such a low price point. But when you actually build it and you have it deployed, you can see how they do it. The electric motors have no encoders or resolvers. Instead, they use a potentiometer as a position sensor. Then they bolt the motor to a gearbox, which uses a worm gear configuration to turn the output shaft attached to a lever. Using a setup like this allows them to keep the cost down. If you had used actuators instead of this setup, it would be considerably more expensive. This system uses motor arms to connect the motor's output to the main cradle assembly in a Stuart-style design. The rod ends used on the arms are not top-shelf units, but they do get the job done, and this seems to be the theme for the H6 chassis overall. Nothing stands out as being of a commercial quality, but in this case, it does make the H6 system available to a lot more sim racers. I do like that the H6 is now using gas-charged struts. This does two things at once. It helps dampen the otherwise jerky motion that you would get without them, and it also gives the motors some help when it comes time for them to lift the cradle in response to the controller's commands. The cockpit section of the H6 is on the flimsy side when you look at the way that the wheelbase solution is designed. Even with the extra support attached, there is noticeable flex in that part of the assembly. I would like to see larger tubes and heavier gauge metal used here. When driving the H6, you do get a full 60OF motion experience. It is not the smoothest or the most refined motion, and I'm glad to see they're using the very good Sim Racing Studio tuning software with this H6 kit. I was able to dial in the motion that I wanted. SRS has a winner on their hands with this software package. I would like to see other sim racing motion companies using it instead of the current version of SimTools. The H6 is also a bit noisy, especially if you prefer your motion to be on the more detailed side. This is due to the 18 rod end connections the H6 uses in its design. You can turn the motion spikes down to help keep this sound on the lower side, but it will always be there. If you buy an H6 motion system, you will get the experience of a true 60OF motion in your racing or your flying games. And the system overall is on the rough side in finish and quality control. At the end of the day, though, the H6 at $3,800 plus shipping doesn't do anything that makes it stand out, but it does do exactly what DOFReality says it will do. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.